So in this video, we are going to be talking about solving systems by using elimination. So here are some steps on how to solve systems using elimination. So the first thing we want to do is we want to write the systems so they are vertically aligned. So they're going to be stacked one on top of the other. And then we want to eliminate one of the variables, and by doing that we're going to be adding or subtracting or multiplying one or both or neither of the equations to make sure that one of the variables will eliminate. We're then going to substitute what we just found into either of the equations and get our x and y. So let's look at this example. So here, what I mean by vertically aligned is that we want to make sure that our x's are on top of one another, our y's are on top of one another, our equals are on top of one another, and our constants are on top of one another. So this is the vertical alignment that we want. What I want to do is I want to find a variable that's in both of the equations that has the same coefficient but opposite signs. So here we have 2 for this x and a 2 for this x. So these are the exact same coefficient. We just want them to have opposite signs. So if you look at the y's, here the y has a coefficient of 1 and the other one's a -5. So they have opposite signs, one's positive, one's negative, but we're missing that coefficient of that 5. So what I want to do is I want to either multiply everything by a negative to get it where I have opposite signs for my x's, or I want to multiply everything in this top one by 5. That way I have those opposite signs and the same coefficient. So I'm going to choose the easier of the two options, and I'm going to multiply everything, and I mean everything in the bottom equation, by a negative. So it's almost kind of like you're subtracting, but I'm going to rewrite everything. So I'm going to go ahead and rewrite the first equation. And I'm going to distribute this negative to everything. So negative times 2x gives me a negative 2x. Negative times -5 gives me a positive 5y. Negative times 13 gives me a negative 13. So this is what I'm looking for. I'm looking for this same coefficient but opposite signs. One's positive, one's negative. And once I have that, then what I'm going to do is I'm simply going to go and say I'm going to add straight down. So I'm going to add everything straight down. So 2x plus negative 2x, well, that's going to cancel. That's gone. That's 0. That's what I want. It's eliminated. So now I have y plus 5y gives me 6y. And then we still have the equals. Negative 5 plus negative 13 gives me a negative 18. And now I just need to simply divide both sides by the 6. And I get y equals negative 3. So now I know one of my ordered pairs. I know that the y is going to be negative 3 in my solution. So just like with substitution, now I just need to go and substitute what I just found into either of the equations. It doesn't matter which one. So I'm going to go and I'm going to substitute it into the top equation. I'm going to take it, substitute it into the top equation. So doing that, I get 2x plus parentheses negative 3, since I'm substituting in something, equals negative 5. So here I have a plus, a negative, so I'm just going to go and change this to a minus. And now this is a two-step problem. I'm going to start by adding 3 on both sides. I get 2x equals -2. Divide both sides by that 2. And I get x equals -1. So now we just found the x of our solution. So again, you can always go and check your answer by plugging in what you found into both equations and making sure that they come out to be true statements. So let's try another one. So here we have, if you are looking, everything is aligned, so our x's are above one another, the y's are above one another, the equals and the constants are all above one another. So I'm trying to see if I have the same coefficients with opposite signs on either of these. And as you can see, one's a 5, one's a 2, that's not the same number. One's a 2, one's a 3, those aren't the same number. And the 2 and the 3 both have the exact same sign already, so that's not what I want. But I have opposite signs on the x's. So what I need to do is I need to go and multiply both equations by some number to make them be the exact same. So I'm going to choose to do this with my x's because I already have opposite signs. So what I'm going to do is I'm going to multiply each of these equations by the other number. So I'm not going to do anything with the signs, just the number. So I'm going to multiply the top equation by 2 and the bottom equation by 5. So I'm doing that. It's kind of like trying to find a common denominator. 2 times -5 gives me -10. 5 times 2 gives me +10. And you can see I have the same coefficient with opposite sides when I do that. So that's why I'm doing this. I'm going to multiply by the other one. You could have chosen to do this with your y's instead. You would have just multiplied the top one by a 3 and the bottom one by a 2, but one would need to be negative in order to get opposite signs. So I didn't want to deal with the negative, so that's why I chose to do the x's. So let's distribute. So I'm going to distribute this 2 to everything, and then in the second equation I'm going to distribute this 5 to everything. So 2 times -5x gives me -10x. 2 times 2y gives me +4y. 2 times 32 gives me 64. Then on to the next one, 5 times 2x gives me 10x. So again, notice that that's what I want. I want the same coefficient with opposite sides. So then 5 times 3 gives me +15y. 5 times 10 gives me 50. So now that I have what I was looking for, where I have the same coefficient with opposite signs, I'm just going to add everything straight down now. So 10x plus -10x, these are just going to cancel away. So this is now gone. So 4y plus 15y gives me a +19y. 64 plus 50 gives me 114. So now I just need to go and divide. So now I just need to go and divide both sides by this 19. And that gives me y equals 6. So now I already know that part of my answer is the y is going to be 6. So again, I just found that. So I need to do a substitution, and I now have 4 different places I can substitute with this 6. I could do it in the original 2, or I could do it in the new 2 that I just did. I do not recommend you doing it in the new 2 that you just did, mostly because you're working with larger numbers, as you can see, and I'm going to pick the ones that are a little bit nicer. So I'm going to actually substitute this into the bottom of the original equation. So I'm going to substitute it into that equation. Again, it doesn't matter which one you do. I just saw all three of those numbers are small, so that's why I did that. So we have 2x plus 3 parentheses, since I'm substituting in the 6, equals 10. So we can start to simplify. So we have 2x, 3 times 6 gives me 18. So this is now a two-step problem. We start by subtracting 18 on both sides, leaving me with 2x equals negative 8. Divide both sides by that 2. And I get x equals negative 4. And again, you can substitute in the negative 4 and 6 into either the both of the two equations, and check to make sure that they come out to be true statements. So when you plug in negative 4 and 6 into the top one, you should get out 32, and when you plug it into the bottom one, you should get out 10. So I have 2 for you to try now. So on the first one, you should have gotten 2, negative 1, and on the second one, you should have gotten 3, 4.